In this video, we're going to talk about raising exceptions. We've already seen how a built-in function raises an exception, and we can handle those. Now, in the function that or methods that we write ourselves, we can also raise an exception. And we can define our own exceptions, but most of the time we can just raise a predefined exception. There are many that are kind of useful. We already seen a value error exception. I'm going to show how to use a type error exception. The important thing is for these exceptions, you want to, when you want to report an error, you want to put a descriptive message telling the caller what really went wrong. Okay, so let's see how we can actually do that. So let's define a function that would just square a number, right? Very simple. We just raise it to the second power, and that's it. Now, it kind of only makes sense if n is a number. It can be an integer or floating point, but let's say we want to limit it to integer for now. So, and we want to tell the user, hey, if it's not an integer, then you really should put an integer as the parameter. So in order to do that, first we can check the type. And I hope you remember how to check the type of anything, a name. So we can just say the type of that. If it's not an integer, then we can raise. That's how you raise an exception. You raise an exception, and in this case the n is of the wrong type, so we do type error, and we'll just say, whatever that thing, whatever that thing is not an int. Okay, so that's the error. Okay, so that's the definition of it. And then now, how do we handle the error? Well, like we said, so I'm gonna say n equal to, let's say, I don't know, 10 for now. And yeah, we're gonna call square. Well, we can print out square and 2. Oh, sorry, n. Right? We know square might raise a type error, so we'll just say try. Let's try to do that. And then we'll say except type error SE. And then if it did raise a type error, then we say, again, just some sort of error. We're going to just print out whatever that error is. Okay, whatever that error is. And let's hopefully, kind of see that it works. Actually, I'm going to give me a moment here. I'm going to just say, yeah, R result. As we said, we usually don't want to do any significant real kind of work in a print statement, and that's what I did. I extract the function call out from the print and put it in its own line. Anyway, so let's run this. So 10, we should not see an error. It should not raise an exception. So we should just see 10 squared. Okay, so that's 100, right? 10 squared is 100. Now, if we put something that is not a number, that's a string, right? Then this should fail. Or, I mean, this type of not a number is not int, so it'll raise a type error. Okay, let's see that in action. And boy, I forgot the format. And okay, all right. So this is not a number. Is not an int. Okay. So hopefully see how that works, but if you want to kind of step through, line by line exactly what it means, is that now, yes, like I said, first you can raise an exception. Now, as I said before, raise is kind of like a return statement. What that does is it immediately terminates the function. Okay, the sort of function exits. So this is almost like a return in that case, right? So it exits, it won't execute any line after it. So that's why it wouldn't even, execute this line. It would just exit right here with the exception. Okay, now how do we capture that exception? Okay, that exception, you cannot capture that exception with an assignment like before, because that's what return does, right? Return will return a value, and that gets put into R here. But raising the exception, when you raise it, it's not going to be a return value of the function. So in order to capture the exception, as we saw just a moment ago, we have to put it in a except clause, and then we do this, except whatever that exception as E. In that case, the exception that is raised inside this function is automatically assigned to the name E here. Okay, so that's the important part. Whatever you raise here, to raise the exception, it's going to get assigned to the name in the except line. And what do we do with E? Like we said over and over, most of the time we just print it out. Okay, hopefully that makes sense. Having said that, now this example is, sometimes we do this, but checking for the type of a parameter in Python is, depending on your requirement, is not a very Pythonic thing to do. And that is simply because Python, as we've seen over and over again, the name does not have an explicit type associated with it. So checking for types in Python is kind of an odd thing. Okay, so, but doesn't mean that it never happens. It happens. Again, that kind of depends on a lot of factors. Probably the most important factor is what exactly are the requirements of the project that you're working on, right? I just want to point that out because it's some of you might question, why are we checking for types in Python? And that's the reason. Anyway, and this is actually discussed in a little more depth in the next class, 3B. Okay, another thing, so I'm kind of wrapping up to talk about exceptions here. This is kind of just the basics. I actually haven't gone into a whole lot of depth in exceptions. Exception can be very sophisticated. Okay, so there are other things that we can talk about is, how do we actually handle multiple exceptions? So far, we've always only handled one type of exception. What if the method can throw different types of exceptions? So we can do that. There's also the exception propagation. It actually, if an exception is not handled in one function, it gets propagated up to the caller and so on. So that's actually one of the reasons that can also make exception very useful. And then there's the user-defined exceptions, but for that we have to know inheritance. So there are a number of things that we can further learn about exceptions. But what we just talked about should be sufficient for now. Okay, and finally, I just kind of cannot go out without mentioning this. Is if you remember, we kind of mentioned the Zen of Python before, and this is kind of some of the most important design philosophy. There's that principle that Python follows. And you can look at this again yourself. I pick out two things that are actually related to exceptions. One of the Zens says error should never pass silently. And so as we've seen before, when an exception is raised and then it's not handled, it actually crashed the program. So that definitely is not getting passed silently, the program crash. Now, then the next item in the Zen of Python is, unless the error is explicitly silenced. That really means, if we expect an exception and we want to handle it, then let's handle it. in that case, our program doesn't crash, and it should continue to work. So just thought those are two kind of fun things mentioned in the Xen of Python that's related to exceptions. All right, I think that's the end of this video.